Hello everyone, this is Y Manikaddi from the branch of CSN. My topic is about the multivariate visualization and subplots. Introduction to multivariate visualization. Multivariate visualization involves graphically representing data with multiple variables simultaneously. It helps in understanding complex relationships and patterns within high dimensional datasets. Effective visualization techniques are essential for exploratory data analysis and decision making. Important, Importance of multivariate visualization. It allows researchers to identify correlations and interactions among variables. Multivariable plots can reveal clusters, outliers, and trends that are not obvious in univariate analysis. These visualizations facilitate better interpretation and communication of complex data. Common challenges in multivariate visualization. This high dimensionality can make visualizations clustered, cluttered, and hard to interrupt. Choosing the appropriate type of plot depends on data type and analysis goals. Overplotting and overlapping points can obscure meaningful patterns. Overview of subplots in visualization. Subplots allow multiple plots to be displayed within a single figure. They are used to compare different variables or subsets of data side by side. Subplots enhance clarity and provide a comprehensive view of data. Benefits of using subplots. Subplots enable the comparison of multiple visualization easily within one figure. They help in organizing complex data views systematically. Using subplots can highlight relationships and differences across variables or groups. Types of multivariate visualization. There are three different types of multivariate visualization. First one is scatter plot matrices are used to visualize pairwise relationships between variables. Parallel coordinate plots represent high dimensional data in a two-dimensional space. Heat maps display correlations or other metrics across multivariables. Scatter plot matrices. They show scatter plots for every pair of variables in a dataset. Diagonal plots often display histograms or density plots of individual variables. They are useful for identifying linear or non-linear relationships. Parallel coordinate plots. These plots visualize high-dimensional data by representing each variable as a vertical axis. Data points are connected across axes, revealing patterns and clusters. They are especially useful for detecting outliers and grouping in multi-feature data. Heat maps for multivariate data. Heat maps visualize data matrices with color gradients representing magnitude and or correlation. They are effective for identifying block patterns or clusters within data. Interpreting heat maps requires understanding of color scales and data normalization. Pairwise correlation plots. These plots display correlation coefficients between variables visually. They help in identifying strongly correlated or independent variable pairs. Correlation plots can guide feature selection and dimensionality detection. Using subplots for comparative analysis. Mul- Multiple subplots can compare different groups or time periods within the same figure. They facilitate side-by-side evaluation of variable distributions. Proper layout and labeling are key for effective comparative visualization. Implementing subplots in Python. Matplotlib provides the subplot and subplots functions for creating multiple plots. You can customize each axis independently within a figure. Subplots can be arranged in grids for organized presentation of data. For example, creating a 2 by 2 grid of subplots. By using a figure axis equal to plot dot subplots of 2 comma 2 to generate a grid of 4 plots. Each subplot can display different variables or analysis results. Custom titles, comma, labels and legends improve clarity. Best practices for multivariate subplots. Maintain consistent axis scales when comparing similar plots. Use clear labels, titles and legends for each subplot. Avoid overcrowding by selecting relevant variables and plots. Interactive visualization tools. Libraries like Plotly and Bogdan enable interactive multivariate visualizations. Interactive plots allow zooming or hovering and dynamic filtering. They enhance exploratory data analysis, especially with large datasets. Applications of multivariate visualization. It is used in finance for portfolio analysis and risk assessment. Applied in biology for gene expression and genetic data analysis. Utilized in market for customer segmentation and behavior modeling. Limitations and considerations. Visual clutter can arise with too many variables or parts. Dimensionality reduction techniques may be necessary for every high dimensional data. Interpretation requires domain knowledge to avoid misrepresentations. Dimensionality reduction techniques. Principal component analysis reduces variable while preserving variance. T-distributes stochastic neighbor embedding visualization clusters in low dimensions. These methods enable meaningful visualization of complex data. Combining techniques for better insights. Use dimensionality reduction alongside subplots for comprehensive analysis. Integrate heat maps with scatter plots to explore relationships. Tailor visualizations based on specific data characteristics and analysis goals. Conclusion and resources. Multivariate visualization and subplots are powerful tools for understanding complex data. Effective visualization depends on choosing appropriate methods and clear representation. Resources include Python libraries like Matplotlib, Seaborn, Plotly, and tutorials for advanced visualization techniques. Thank you.